Hello everyone, myself Deepak Kumar and I am an undergraduate student of Indian Institute of Information Technology, Design and Manufacturing Kannur, and my team members are Priya Sahanand, Subham Gahlot and Saibrat Reddy, and we have made this project as a part of Embedded System Internship at Emertxe Technologies. Now I will demonstrate our project Microwave Oven Simulation, which is made during the internship at Emertxe. First of all, I will introduce you all to the topics learnt during the internship that we have learned. And the first topic is Introduction to C. In Introduction to C, we have learnt about the basic of C. And the next, we have learnt about the conditional statement, loops, operators. In conditional statements, we have learnt about that if else. And in loops, we have learnt about for loop, while loop, and do while loop. In operators, we have learnt about mathematical operators, logical operators, and arithmetic operators. Then after we have learnt about arrays and pointers. After that we have learnt about functions and strings. Then after that we have learnt about that storage classes. And in storage classes we have learnt about how RAM and ROM differs. Then after in the second week we have learnt about the we have introduced about to the embedded system and microcontrollers. And in this we have learnt about the difference between microcontroller and microprocessors. And during third week, we got to know about three softwares that are MPLab IDE, XCB, PiximLab, and during this period, we have used microcontroller PIC16F877A. We also learned about its interfacing through various peripherals. Now I will go through the whatever the contents we will cover in this presentation. And the first will be what is microwave ovens, and then requirements that we for this project, then microcontrollers and microprocessor defense, then Pixim lab, then CLCD, then matrix keypad, then ISR, then timers, and at last we will see the demonstration of this project.
Now I will tell about what is the microwave oven. Microwave oven is used to heat the food using microwave, and which is of the form of electromagnetics wave. And there are several modes in various microwave wave oven, and we are going to implement four modes, and they are micro mode, grill mode, convection mode, and start mode. Now I will tell about the micro mode, and in micro mode is used to cook food in a traditional way. It uses a maximum power of 900 watt, and in this the maximum time that we can set is of 60 minutes. And in grill mode, this grill mode is used to cook meat and bread, and it works as the micro mode, but the purpose is to cook meat and breads. Convection mode. In this mode, users can set the oven to preheat for a particular temperature, and this preheat temperature can take the 3 minutes in the oven. And after the preheat is done, then user can set the timings according to the requirements. And what are the requirements of this project? And the requirements of this projects are MP Lab IDE and XC8 compiler, PI Pixim Lab, and MP Lab ID is where we will code, and XC8 compiler is used for the compiling the code, and Pixim Lab we will see the output in that. And the microcontroller PIC16F877A has different components like 16:4 CLCD, tactical switch, MKP, and timers. And that MKP is that mask key. And now my friend Bharat will continue the microprocessor and microcontroller.
As Deepak said, I will be explaining about microcontroller and microprocessor. Microcontroller is a component. It is a chip which is less flexible and less design compatibility, whereas when compared to the microprocessor, like microprocessor has a more flexible and more design complexity. Next, microcontrollers and microprocessors are like an integrated circuit which is capable of being performed to a specified task, which is like when we program a task, we can communicate with the both microcontroller and microprocessor. Um, it has a design restriction such as memory size, input and output capabilities, and peripheral functions. Like for example, memory size has means microprocessors has a limit of memory size, so it has a memory restriction. And input and output capabilities have microcontroller have input and output uh, restriction capabilities. Uh, Microcontrollers based on applications and performance, price capabilities, and tools and special capabilities. We have selected the specific capable. Based on that, we have selected microcontroller and microprocessor. In the project, we have used MKP. MKP means like matrix keypad. That is like in daily necessities, we can say it like as keyboard. Keyboard, how we use for multiple input, multiple output, like it is on and off. You can select whatever the numbers or alphabets. Like in microwave oven, it's like one we need to keep the time, right? So we used the MKP to keep the time, and it has some functions like here they have used like this is used when more number of user inputs are required. Like for example, in keyboard, right, we used to type with a like specific speed. Like this also it's like to keep the time or timer. CLCD is like character liquid crystal display. It has two types, like 16 by 2 display, 16 by 4 display. 16 by 2 is display is like it has up to two lines, and 4 display 16 by 4 display is like 4 lines. Because here we need to keep in micro oven we have 4 functions like start, and what are the 3 types like roasting, crispy, some functions, right? So we are using 16 by 4 display here in the micro oven project. It also displays ACI characters and some special characters like say A alphabets and numbers, stars, like dot, like dot symbols. And it has 2 types of communication modes like 4-bit and 8-bit. In Pixim Lab, or this is the Pixim Lab architecture. Like we have used PIC 16F877A, and like digital keypad, like we have used MKP, and buzzer is like for whenever the timer is completed. So we have used buzzer, LEDs, and GPIO, I2C, RTC, and RTC or EEP ROM. LM35 is like temperature sensor, which is used to at sense the temperature, like for how much specific type of temperature to keep the cooking for like micro oven. And ADC and CLCD is like for the display. I have bold like interrupts. These are the like interrupts. Interrupt is a communication process set up in a microprocessor or microcontroller, which is internal or external device requested to request the MPC or MCU to stop the processing. It's like whenever the MPMC, it is like a communication between a microprocessor or microcontrollers. Basically, in microprocessor unit or microcontroller unit applies the request and attends the request. Like when we send the X file to the microprocessor microcontrollers, it runs and returns the specific output for ourselves, right? That it act like a interrupt between them. It's like it act as a communication between us and the machine. ISR is like interrupt service routine. Whenever an ISR is a software routine, that hardware invokes the response to an interrupt. ISR attends the request of an interrupting source by clearing the interrupt flag. It's like whenever the interrupt happens, microprocessor unit or microcontroller unit flags that interrupt and runs the next instructions, so that process will take. Otherwise, if the an interrupt will happen, process will stop, right? So it is an interrupt service routine. After the interrupt came, uh, next instruction will run by clearing the flag. So it is an interrupt service routine. Timer is an important application, like forever the how much time to we need to cook or something. That's why we use timers. Timers like basically for running the program for how much time it need to run, how much time the process you need to take for cooking, or like something like in this project like cooking for some chicken or something. Timer is as here it has shown, timer is an important application in an embedded system, which is a default peripheral which maintains the timing of an operation in sync with a system or system clock or an external clock. Like system clock or external clock means like for how much time we need to process, we need to create that process so that it will be happening for this much specific of time. Like it will be explained in the explained by Priyash while he is simulating the program. It has many applications such as measure time and generating delays, like delaying the time and measuring the time. Timers will take care of it. Timer is like an counter also, by called as a counter. It is a software designed to count time intervals between the events. Next, our code and another thing will be explained by Shubham.
Thank you, Bharat. Hello, everyone. I am Shubham from IIIT DM Kannur EC branch. Now I will continue with the explanation of my code. Here, initially, I have initiated my main function at first. Here, I have assigned my key number to the operation mode light, key number 1 to the operation mode micro mode, key number 2 to the operation mode grid mode, key number 3 to the operation mode convention mode, and key number 4 to the cooking mode display, where it will show the display. In the next section, I have assigned the operation call, where I have assigned the function of operation mode like cooking display mode, in which I have assigned different types of mode like micro mode, convention mode, grill mode. These mode will assigned in detail. And at last, I have assigned the reset flag, where we can reset our function. Next, in the next section, I have assigned the power on screen, where I have in the next screen I have names of the mode on the display screen. After that, I have assigned the cooking mode display, in which there are 4 options: micro mode, grill mode, convention mode, and start. In this, we can choose any of the number. Like for 1, if we choose 1, we get the micro mode. If we press key 2, then we get the grill mode, as we have initialized previously in that code. At the end, I have assigned the clear display mode, which can clear the display and we can start from the initial position. In the next section, I have set the time set function, in which we will set the microwave oven timer. Initially, we have set the timer seconds is 0, timer minute is 0. And as you can see on the screen, my set time, which is in and seconds, is 00 initially. As in further, we can change our time accordingly. In the next section, now I have initialized some different function which can check whether my door is open or closed. If my oven's door is open, then the buzzer will on and it will indicate that our door microwave door is open. As if it is closed, it buzzer will not blow. In the next section, I have assigned the time display in which we can check the timer of the oven. Here, as you can see, the key 4 shows the start and resume, key 5 shows pause, and key 6 shows stop. If we press any of the keys, we will get the command to do any of these things like for if we press 4, we can start or resume. If we press 5, we can pause, or if we press 6, we can stop our microwave oven. Now, in the last section, I have assigned the set temperature function in which I have set the temperature of the microwave oven in degrees Celsius, where where my maximum temperature is 250 degrees Celsius. So here, this is my code. Now I will show you the code by running. Now, if we click on the build project, we can check if our code is right or not. Here you can see it is compiling our code. In this section, we get that our code is successfully completed. Now, my friend Priyesh will continue and explain you how it's working in that microcontroller. Thank you.
Thank you, Shubham, for explaining that code. I, PSM, will further explain the Pixim SimLab and how we will run that code in the simulation. First, we will load the hex file generated by the code through this file button. We will load hex and go to the file location. And now the code is loaded on hex. Now it is giving us 4 options: microgrid convection and start. We will go for the micro by clicking on one. 900 watt power. We will set the timer as per the requirement. It will go till like 59 minutes is the maximum limit. We will put something about 10 seconds and enter. Now as we can see, the fan is running and this is a heater module for PIC 16F877A, and we can pause it by with button 5 and again start it with 4, and with 6 we can reset the code. So this is the main simulation. This module is PIC 16F877A microcontroller, and for seeing this entire menu, we have to select from LCD HD 44780 16 times 4. In 16 times 2, the code will not, the entire interface will not be visible. Furthermore, this is a 8-bit microprocessor. We will also do it for grill, like clicking second and putting as 10 seconds temperature. Again, the fan is running and cooling the heater. We can again pause it with 5 and stop it with 6. Thank you. That's all from the demonstration for the simulation.